We'll proceed in solving TDS. Okay, so TDS calculus problem. How to solve TDS calculus problem? Rather than going problem by problem, we would try to find a generalized approach to solve a calculus problem. First of all, we should understand that this is a calculus problem. How we understand this is a calculus problem? If anything that is related to algebra, more or less, and there is dependency and independency that comes into picture, then we say this is more or less calculus problem. And calculus problem are in two shapes. One is integral calculus and one is differential calculus. How I find my problem is in integral calculus or differential calculus. If we see multiplication, then it is candidate for integral calculus. And if it is division, then it is candidate for differential calculus. There may be a chance where we need multiplication and division together, then we need to use integral calculus and differential calculus, both of them. Anyway, we will see that. Okay, are you confident that integral calculus is mere algebraic multiplication? I am certain about it. Only thing is that when you multiply two items, one item should be dependent upon other. Are you sure that division of two items leads to differential calculus? Yes, if it is algebraic and numerator is dependent upon denominator, then it is differential calculus. Mind blowing, amazing. Okay, now we will proceed. So one thing that we have seen how to calculate the weight of a sphere, and we did long discussion on that, how to calculate weight of a sphere. Please watch all the previous video in this series, that is tedious calculus problem, how to solve, how to calculate weight of a sphere where density is provided and volume can be calculated, and density is variable. Density is not constant all around the sphere. Okay, density is dependent upon x, y, z coordinate. In that sense, how to calculate weight of a sphere? I have a very pretty simple question. Consider I have a line x equal to y. I have a line x equal to y. What is x equal to y line is? Whatever is x, that is y. Hop, 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 hop. Again, dependency and independency is there. X is independent and y is dependent. Equation of a line is y equal to x or x equal to y equal to x. Whatever is x is, y is same. That is the line. If this is x-axis, this is origin and this is x-axis. What is y equal to x? This is y-axis. Y equal to x is exactly a line that touching origin and make 45 degree from the x-axis. Whatever is the x, that is the height. If you take x 10, height is 10. That is y equal to x and it is a line. Okay, very nice, very nice, very nice. Okay, can you calculate the length of the line between origin and a point called 4, comma 4? This is what I want. What is the length of the line that is from origin to 4, comma 4? Okay, anyone would say, no problem. 4, comma 4 means height is 4, width is 4. 4 square plus 4 square square root. That is the length of the line. But problem will be much tedious in other example that will be based upon this. So let's try to find out not through Pythagoras theorem. Let's try to find out through any. Okay, if I say line equation is y equal to x square, line equation is y equal to x square. Okay, what is the length of the line between section 0, comma 0 and point called 4, comma 16? This is x axis and this is y equal to x square. This is x axis and this is y equal to x square. What is the section of this curve length? This is a curve from 0, comma 0 to 4, comma 16. There is a curve that is y equal to x square. What is the length of this line? Now solve through Pythagoras theorem. Okay, anyway, we will do through Pythagoras y equal to x only. Slowly we will understand. Okay, so okay, we are calculating the length of the line section of a line y equal to x, and that is from origin to point 4 comma 4. Okay, if I give you a vector, then can you find the length of the line? Yes, quickly I can find the length of the line. Okay, the vector equation of the line y equal to x is I plus j. The vector equation of the line y equal to x is I plus j. Now get the length from 0 comma 0 to 4 comma 4. Then it will be, what is the length of a vector I comma j, I plus j? That is square. It is looks like Pythagoras only. Square root of 2. Square root of 2. But this is something like, it is a vector that is between 0 comma 0 to 1 comma 1. If x is 1, then length is the square root of 2. If length x is 4, then it will be 4 into a square root of 2. If you watch very minutely. Okay, the length of a line, length of a vector I plus j, the length of the vector I plus j is square root of 2, provided the x-axis section is 1. Then multiply by x-axis section. Are you sure about it? Yes, I am sure about it. Okay, consider a vector that is I plus 4j. A vector is I plus 4j. Means this vector is passing a point called 1 comma 4. If that is the scenario, 1 comma 4, then what is the length of the section of this vector? That is 0 comma 0, 0 comma 0 to 4 comma 60. I believe it will pass through 4 comma 60. Okay, what is the length of the line I plus 4j? That is 4 square plus 1. That is square root of 17 is the length of the line. Length of the line is a square root of 17 when the x-axis section is 1. If x-axis section is 4, then 4 into a square root of 17. Are you sure about it? Okay, anyone calculate it? Okay, what is the vector that is passing 4 comma 16? 4 comma 16. Then that is 4i plus 16j. What is length of this? That is 4 square plus 16 square root. 4 I can take it out. Then 4 I can take it out. 4 square plus 16 square root. So if I can rewrite it as 4, 4 if I take it out, I mean if 16 if I take it out, 4 square plus 16 square. Okay, 4 square, 16 I can, if I take it out, it becomes 1 square plus 16. Same as 4 into square root of 17. So if I have any vector, and if I compute the magnitude of the vector, provided the x component is 1, the net length of the vector is how much x I am taking. This is something generic anyway. Now the question arises at the beginning only. What is the length of a section of a line that is y equal to x from 0 to 4 comma 4? That is the original question. How we can solve? So I know that this problem can become a curve problem. Y equal to x square, y equal to sine x. Then we cannot use Pythagoras theorem. So better go with the generic approach that will be used in any kind of curve equation. Any generic approach that will be used in any kind of curve equation. Okay, but one thing I know, if I know vector, and a vector is in form of I plus whatever j, calculates its magnitude and then see I is from where to where, just multiply it, and that is the length. What is the vector form of a line that is y equal to x? How to find a vector? To find a vector, take any one point as origin and take any other point. If that point is x comma y, then vector equation is xi plus yj. Okay, that is true. If I take any point x comma y and from origin, I draw a vector, then that is xi plus yj. My idea is x should be 1. Then in that sense, xi plus yj, same thing I can write if I divide by x, it will be I plus y by xj. I plus y by xj. That is the generic equation of a vector. A a vector has 2 points. One is origin and another x is 1. According to x is 1, what is the y? That is y by x. Huh? Or if I go with the differentiation, then dy by dx. So net vector equation is I plus dy by dxj. Any point if I take, and that point is x comma y if I'm thinking, but I want x as 1. In that sense, it becomes 1 plus y by xj, or I plus dy by dxj, whatever it is. Now, what is the vector equation of this line y equal to x? Okay, if I take any point here, any point on the line x comma y or x comma y, that point is called P. What is the position vector? P. Hop, hop, hop. This is x-axis, this is the line. That is y equal to x. I take any point on the line called P. I take any point on the line called P. Okay, then then the position vector of this position vector may not be related to the y equal to x. Like I take y equal to x square, and if I take any point P here, then this from origin a line that is connecting P, that is the position vector, that is independent of the curve line. So if I take any point P on the line that is x comma y, then position vector is xi plus yj, xi plus yj. Anyway, now we have two things. One thing, what is your vector? Vector is nothing plus but I plus y by xj. Are you sure? Yes. If line is y equal to x, then I plus y by x. Y by x is always 1. If you take line y by x at any point on this line y equal to x, y by x is always 1. Then the equation of vector is I plus j indeed. Okay, other fundamental is take any point on the line called P. Then the P is x comma y. The position vector is xi plus yj. Then dp by dx, change in position vector with the unit change along x-axis is I plus dy by dxj. Oh, same thing what we were saying. So if I have a curve and I take any point on the curve P, and if I differentiate with the x, then I get the vector form, knowingly, unknowingly. That is xi plus yj d of dx, that will become I plus dy by dxj. That is nothing but a vector what I want. So vector representation of any curve at any point, I would rather say, if it is a straight line, then the vector representation of the straight line. Or if it is a curve, then at any point of the curve, if this is the curve, then vector represent everywhere vector will be different because vector is a straight line. So if there is any curve, oh, the curve is gone. Okay, so I have to find the curve. Hope if I do like this. Okay, anyway, the curve equation is y equal to x square. So this is the curve. This is the origin, and y equal to x square is this. Now, every moment, if I want the vector equation will be tangent at that point, and it will be vector equation will be tangent at that point. So everywhere the vector equation will be different. So it will be algebraic, and that will be I plus dy by dx. I plus dy by dx is nothing but dp by dx. If I have a position vector, then dp by dx is nothing but I plus dy by dx j. Okay, very nice. Thank you very much. So I know how to calculate the vector representation of a line or a curve. Vector representation of any line is nothing but I plus y by xj if it is a line. If it is a curve, then I plus dy by dxj. Okay, I'm not going through dp by dx. Straightforward. Okay, if I want a vector, what is a vector? Position vector. Vector is nothing but a line that is passing through 2 points. One point is x1 y1, another point is x2 y2. Their vector is x2 minus x1 I plus y2 minus y1 j. That is a vector. If I have any point, if I have any point where x is 1, if there is a line, if there is the equation of a line, line can be y equal to 2x, line can be plus some constant, y equal to 4x. If there is a line called y equal to 4x, then when x is 1, then how much is the y? If x is 1, then how much is the y? That is y by x. If y equal to 4x, then y by x equal to 4. Then the point is 1 comma 4. The vector equation is I plus 4j or I plus y by xj or I plus dy by dxj. Oh, but I plus dy by dxj is here the representation of a vector for a line. Then xi plus yj is a representation of position vector p. Looks like dp by dx is the vector. Yeah, that is I plus dy by dxj. Oh, understood. So if I calculate dp by dx, if I take any point p and calculate dp by dx, then I get the vector equation I plus dy by dxj. Okay, we are doing too many fundamentals. Okay, very much. Thank you very much. So now the original question: what is the length of the line? Length of the line section line equation in y equal to x from origin 0 comma 0 to 4 comma 4. Okay, what is vector representation for this? Vector representation for this is I plus y by xj. Then it comes as I plus ij. Okay, then length is square root of 2. When x section is 1, x section you want 4, 4 into a square root of 2 is the length of the line you are talking about. But from this, I learned that how to calculate a vector representation of a line when x section is 1 is dp by dx. Okay, okay. I think you understood. Okay, so you understood very well. So what is the equation? What is the length of a line from section origin to 4 comma 16? Okay, what is the equation of line? Y equal to x square. Indeed. So y equal to x square is the equation of a curve. What is the length of this curve from point 0 comma 0 to 4 comma 16? Okay, now I know the position vector. What is your position vector? Position vector is xi plus yj. dp by dx will give me the vector representation of this curve. The dp by dx is 2x. What is the vector representation of a curve? That is I plus dy by, I'm sorry, dp by dx is vector representation of the curve. That is t is xi plus yj. If this is the curve y equal to x square, I take any point p here and from origin I draw a position vector. If that is the case, then dp by dx is I plus dy by dx j. Then dp by dx, I'm not talking about p, dp by dx. dp by dx is I plus dy by dxj. I plus 2x, dy by dx is 2x, 2xj. Okay, now calculate the magnitude of this and you get the length of this curve when x equal to 1. Make sense? Then length of the curve is 1 square. 1 square, length of the curve is 1 square plus 2x whole square root. 1 plus 4x square root. That is the length of this curve provided x length is 1. 1 plus 4x square root. Okay, now you got it. Now what is the length of this section when length is 4? 4 into square root of 1 plus 4x square. That is the length. Hop, 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 hop. Now there is a problem. I tried multiplying two items. What are you doing now? We are trying to multiply the magnitude of a vector, that is for length equal to x length is 1, into the net x I want. Okay, if you want in this fashion, then you are trying to do multiplication. If you are trying to do multiplication, then let's watch if it is algebra. Yes, yes, it is algebra. 1 is square root of 1 plus 4x square, algebra. And then I'm trying to find for any length 4, any length x, then it will be a square root of 1 plus 4x square into x. You're trying to multiply two items when the right hand side x is independent. I can take any x value 1, 2, 3, 4. Left hand side, that is, I have taken the magnitude of a vector that is dependent upon x, a square root of 1 plus 4x square, and 1 is x. One is dependent and one is independent. You are trying to multiply it. This is a fit case of integral calculus. If you try to multiply two items, and that is algebra, and one is dependent on other, we are trying to multiply the vector magnitude, that is square root of 1 plus 4x square, with the length of x-axis, any x, then it is the any x that is independent and the magnitude is dependent. It falls in the section of integral calculus where one is dependent, that is called integrand, and one that is independent, it is called differential. Now this form will be transformed into square root of 1 plus 4x square into, instead of x, I would say dx. Okay, dx, and then integration from 0 to 4. Okay, now if someone has really guts to find it, then he can try it out. I don't know how much it will come. I can take out 4 from here. Then if I take out 4 from here, then it will be a square root of 1 by 4 plus x square, and 4 will come out as 2. Then 2 into square root of 1 by 4 plus x square. This will form, I believe it will come at tan inverse x by something 1 by a, that form it will come 0 to 4. It is not that straightforward. Anyway, okay, but concept is clear. I understood the concept. Thank you very much. I understood the concept behind whatever you're saying. Can we apply this in your y equal to x equation, and let's try to find out if it is really the thing. Okay, now y equal to x, if I say what is the vector, then it is I plus j. Magnitude of I plus j is the square root of 2. Square root of 2 dx, and 0 to 4. Square root of 2 will come out, square root of 2 will come out dx. Integration is x, 0 to 4. 4 into a square root of 2. Okay, if line equation is y equal to x square, y equal to, I'm sorry, y equal to 4x, that is the line equation. Then it is dy by dx equal to 4. 1 plus 4 square root of 17 dx, 0 to 4, 4 square root of 17. Okay, so what is the concept that we are trying to show here is, if you see multiplication, our idea is not to calculate the length of a line section. The idea is, okay, if that is true, then can you calculate the length of a line section? That line equation is y equal to 4x from x equal to 2 to x equal to 6, whatever the section is. Let's change the integration 2 to 6. That's it. Anyway, the concept here is not to find the length of a line. Idea is where to use integration calculus, where to use differential calculus. We were trying to find y by x. We started with a discussion that we can find a line length if I know the vector, and calculating the vector magnitude through that I can calculate the line length. Vector equation is nothing but I plus y by x j, but I saw y is dependent upon x because that is the equation of a line. Any line, y equal to what? In that case, y by x will be transformed into dy by dx because it will fall in differential calculus. Differential calculus means if we are dividing two items and numerator is dependent upon denominator and denominator being an independent component, then we will change y by x to dy by dx. Better word is y by dx. Actually, it should be y by dx. Okay, but it is written as dy by dx. If I am multiplying y with x and y is dependent upon x, then y into x will be transformed into y into d of x. Then start the kind of integral calculus. Dy by dx, start the differential calculus. Okay, in that fashion, can we calculate the length of a line that is sine x? Length of the line that is sine x. Okay, sine x 0 to pi. What is the length of this curve that forms the sine x? Okay, if that is the case, then what is the vector notation? dp by dx, I plus dy by dxj, I plus cos xj. What is the magnitude? 1 plus cos square x square root. 1 plus square root of 1 plus cos square x dx. Integration from 0 to pi. That is the length of this curve. Okay, very nice. I don't know what is the length of this curve sin x, but this is how it is. I know the length of a circle, that I know how much it is. Okay, try to find the length of a circle for half of the perimeter. Okay, half of the perimeter. If I draw a length of a circle, half of the perimeter, then consider the circle is centered at the origin. Then minus a to a. Please find out. There is a circle and it is centered at the origin. If it is centered at the origin, then minus a to a. A is the radius. What is the perimeter? Okay, tell me what you know. I know perimeter of a circle is 2 pi a. This is pi a. I know the answer. Pi a. Now find out the length of the curvature of a circle, half. Okay, find out. Okay, now what is the equation of the circle? Y equal to square root of a square minus x square. X square plus y square equal to a square. Y equal to square root of a square minus x square. Then vector equation is the position vector. If I take a circle, I take any point P, then position vector is xi plus yj. dp by dx is I plus dy by dxj. dp by dx is the exact formulation of a vector. That is I plus dy by dxj. That is I plus dy by dx. That will form as minus x by square root of a square minus x square. Differentiation of square root of a square minus x square is minus x by square root of a square minus x square. Oh, I know the vector now. I plus minus x by square root of a square minus x square j. Now the net length will be magnitude of this vector into x. And x is minus a to a. I found out. Okay, try now. Okay, then it is 1 plus x square by a square minus x square. That will be square root. That will be settled down as a square by a square minus x square square root. That will be a. A will come outside. 1 by square root of a square minus x square dx. This is a perfect, I know this. This is perfect for sine inverse x by a. 1 by square root of a square minus x square is sine inverse x by a. Okay, now x is minus a to a. If I give a as a numerator a, then sine inverse a by a 1, that is pi by 2. Minus a sine inverse minus and the sine inverse minus 1, minus pi by 2, minus plus pi into a, pi a. Okay, so here we use differential calculus calculating dy by dx, and here we use integral calculus, differential calculus, when we were trying to get vector notation or notation of a curve, and then we used integral calculus when we were trying to calculate the kind of the net magnitude of the length. there is bigger to it. I believe it is all right. This is, if you see how we try to find the length. Length is, if I have a position vector, the length is synonym of position vector. Length is not synonym of dp by dx. If I say dp by dx, this is called velocity vector. Position vector is the actual length vector. dp by dx is velocity vector. If I want to get back the length, then dp by dx, I have to multiply back with the dx, then only I'll get the p back. If somebody is saying I am giving you p by x, find p, multiply it by x, you get the p. If I have those, so the length is actually is analogous to p, not dp by dx. dp by dx is velocity vector. So dp by dx, if I have, calculate the magnitude of this velocity vector, because you're trying to calculate the length, right? Calculate the magnitude of dp by dx and get back the p by multiplying it by dx. So dp by dx magnitude multiply with by dx, you get the p back, but not in the name of vector, in the name of its magnitude. Hop, 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 hop. If I say I know p by x and p is vector, then you have to get back the vector. Then p by x into x, you can get back the vector. If you know dp by dx, multiply with the dx, you will get the p back. But I don't want p back. I don't want position vector back. I want length of the position vector. So dp by dx magnitude, because dp by dx will again be a vector. If p is a vector, then dp by dx again it will be a vector. dp by dx, whatever is vector is there, that is called velocity vector. Calculate magnitude of this velocity vector, because you want the length of the vector, right? So dp by dx. Okay, then I can find the p vector length only. You can't do, because that is coming as algebra, and then dependency and independency coming into the picture. So calculus will come into the picture. So dp by dx, calculate the magnitude, that will what you want, and that magnitude multiply with the dx. So that is called velocity magnitude. Velocity magnitude into displacement will give the p back, and that will be the length of the curve. This is high level explanation, but in depth, whatever we talked about. Don't mind supporting us. +91 in the India country code 9483160610 is the telephone number. 9483160610 is the telephone number. +91 is the India country code. This is how it is. We will proceed on this.